From 49 to 52, evaluate the indefinite integral. Illustrate and check that your answer is reasonable by graphing both the function and its antiderivative. Take big C equals 0. The integral of x times open x squared minus 1 closed to the power 3 dx. The integral of tangent squared theta, secant squared theta d theta. The integral of e to the power cosine x times sine x dx. The integral of sine x cosine to the fourth power x dx. From 53 to 73, evaluate the definite integral. The integral from 0 to 1 of cosine of pi t over 2 dt. The integral from 0 to 1 of open 3t minus 1 closed to the power 50 dt. The integral from 0 to 1 of the cubed root of 1 over 7x dx. The integral from 0 to 3 of dx over 5x plus 1. The integral from 0 to pi over 6 of sine t over cosine squared t dt. The integral from pi over 3 to 2 pi over 3 times cosecant squared of 1/2 t dt. The integral from 1 to 2 times e to the power 1 over x squared dx. The integral from 0 to 1 of x times e to the power negative x squared dx. The integral from negative pi over 4 to pi over 4 of open x cubed plus 4 tangent x closed dx. The integral from 0 to pi over 2 of cosine x times sine of sine x dx. The integral from 0 to 13 of dx over the cubed root of open 1 minus 2x closed squared. The integral from 0 to a of a times the square root of a squared minus x squared dx. The integral from 0 to a of x times the square root of x squared plus a squared dx, where a is greater than 0. The integral from negative pi over 3 to pi over 3 times x to the fourth power sine x dx. The integral from 1 to 2 of x times the square root of x minus 1 dx. The integral from 0 to 4 of x over the square root of 1 plus 2x dx. The integral from e to the power the integral from e to the power 4 dx over x times the square root of natural log of x. The integral from 0 to 2 of open x minus 1 closed times e to the power open x minus 1 closed squared dx. The integral from 0 to 1 of e to the power z plus 1 over e to the power z plus z dz. The integral from 0 to big T over T times sine of 2 pi t over big T minus alpha. Close redoing that. The integral from 0 to big T over 2 of sine open 2 pi t over big T minus alpha close dt. The integral from 0 to 1 dx over open 1 plus square root of x closed to the power 4. Verify that f of x equals the sine of the cube root of x is an odd function, and use that fact to show 0 is less than or equal to the integral of the integral from -2 to 3 of sine the cube root of x dx is less than or equal to 1. Now use a graph to give a rough estimate of the area of the region that lies under the given curve. Then find the exact area. Y equals the square root of 2x plus 1, where x then is x is greater than or equal to 0, but less than or equal to 1. Y equals 2 sine x minus sine 2x, where x is greater than or equal to 0, but less than or equal to pi. Evaluate the integral from -2 to 2 of open x plus 3 close times the square root of 4 minus x squared dx by writing it as a sum of two integrals, interpreting one of those integrals in terms of an area.